Okay, so we're on example 6 on page 8. We're continuing chapter 1, section 1. Example 6 says, determine if the following points are on the graph of the equation 2x minus y equals 6. Okay, so if we think back to this equation, it has two variables. All right, anytime we have two variables, it is impossible to list all of the solutions that work for both variables because there's an infinite amount of solutions. So, for instance, forget this problem for a second. What if I had something like x plus y equals 10, and I told you name everything that could work here? All right, what all could you use for x and y that would work? 5 and 5, 4 and 6, 7 and 3, 8 and 2, 9 and 1, 10 and 0. Okay, but you could also use 4.5 and 5.5. You could use 2.3 and 7.7, right? You could use all those decimals. You could use 80 and negative 70. All right? So you see there is an infinite amount of solutions that will work. So it's impossible to name them all. So what do we have to do to show all the solutions to this equation? We graph it. All right? And when we graph this equation, we get a line, and that line tells us, hey, all the points on the line, those are solutions. Those are things that you can plug in and make work. All right, so after that quick refresher, now let's look. Now let's look back at this example. Let me find my eraser. I just messed up. It's okay. I made a new slide and it stopped my recording. But we're still recording, so you get to hear this for forever. How you like them apples? So now, we want to know, does the point 2, 3 work for this equation? So what is going to happen for 2, 3 to work? Well, that means when I plug them in, I should get a true statement. All right, so let's look. This would be 2 times x, but in this one, my x is 2, minus y, which is 3, equals 6. That says 4 minus 3 equals 6. 1 equals 6, and that is a false statement. So, is the point 2, 3 on the line? No, it's not. Okay, if it was on the line, you would be left with a true statement. Now, let's try the other one. What about 2, negative 2? We're going to take that and plug it into our equation. That would be 2 times 2 minus, all right, my y is negative 2. So minus negative 2 is just plus 2 equals 6. That gives me 4 plus 2 equals 6. So that means, yes, this point is on the line. So, here we're told to graph this equation, y equals negative 2x plus 3. Okay, so how would you graph this? Now, there's several different ways you could graph it, but I bet I know the way that most of y'all would choose to graph this right now. How would you graph it? Start at 3. Why? Because it's the y-intercept. So this is in slope-intercept form, so you would graph it from slope-intercept form. Okay? And that's perfectly fine. That is a valid way to work the problem. And so we could do that. We could start at 3 as our y-intercept, plot a point, and then the slope is negative 2. So that means we would go very good. Down 2 to the right 1. I don't know why. Why did it not? Okay, so here's my table, or my graph. I don't know what happened. Don't know why it didn't paste the way it should have. But the way we were talking about, the y-intercept is 3. So I would go up here on the y-axis to 3. And then we'd use the slope that was negative 2 to go down 2 to the right 1. Down 2 to the right 1. Right? Or I could go up 2 to the left 1. Very good. All right, and that would also be on that line. And so through all these points, you would connect them to get your line that was the solution. Okay? That's fine if that's the way you would graph this. Now there's a few more ways that we could graph it, and the way that the book talks about here is you can always graph something by choosing some x's and finding out what their y should be. Okay, and that's the first way you ever learn how to graph. So say that my x's I plugged in were -2, -1, 0, 1, and 2. Just plug them in, see what the y value is, and you could graph those points. Okay? We won't take the time to do that, but you can see it in your book. But if you graph it slope-intercept form, that's fine as well. Okay, so here's our next one. It tells us to graph the equation y equals x squared. So we talked about it a little before, and we remembered that x squared graphs to be a parabola. All right, so does anybody remember how you graph parabolas in Algebra 2? You didn't graph them? Okay, that's fine.
We never graphed much, we just learned how to.
Okay, well, we're going to graph later in this class, parabolas, but the way that they're showing us right now again is to pick some x values, figure out what their y values are. So for this particular case, the best x's to pick are -2, -1, 0, 1, and 2. Now, why are these the best to pick? Well, let's talk about that for a second. Any parabola that you'll ever draw always has a line of symmetry, right? Where it's symmetric on both parts. Now, how can I find what that line of symmetry is? Does anybody remember? Okay, we were given a formula, an equation that says x equals -b over 2a. Does that look familiar? Okay. What this does, it tells us where my axis of symmetry is, or the x coordinate of my vertex. Okay, so for this particular problem, what is my b term? Well, there isn't one, right? It's 0. And then what's my constant term? It would be 0. So if I plugged into the formula here, -b over 2a, that would be -0 over 2 times 1, which simplifies to be 0 over 2, which is 0. Which means 0 is where it's symmetric. Okay? Since 0 is my axis of symmetry, then I want 0 to be the middle digit that I plug in. Okay? So I'm going to pick in some values that are less than 0, like -1, -2, and I'm going to pick some that are greater than 0, 1 and 2. And I put that 0 in the middle because it is the axis of symmetry. Okay, so let's plug in. If I plug in -2 and square it, that gives me 4. -1 squared, 1. 0 squared, 0. 1 squared, 1. 2 squared, 4. Okay? And then we plug this in. So I've got 0, 0, 1, 1, 2, 4, -1, 1, -2, 4. Right? And I get a nice parabola shape right here. Right? And when you plug in that x for your vertex, right, which in this case happened at 0, then you know that's either going to be the lowest or highest point. It never drops below that. So always remember when you're graphing these parabolas to find that axis of symmetry and plug it in the middle. Okay, so like, for instance, if I was given this problem, if I told you y equals x squared minus 8x, and I told you to graph it. Okay, well, we know right now the way we're going to graph this is to choose some x's, find what their y is. Now let's figure out what x's I need to choose. The axis of symmetry happens at -b over 2a. So in this problem, that would be negative, what is my b? The b is -8. So minus -8 is what? Minus -8 would be +8 over 2 times a. What's my a value? 1. So that's 8 over 2, which is 4. So that means 4 needs to be that middle value I plug in. So I'm going to pick some things less than 4 and some things greater than 4 to plug in. And we're not going to take time to do that, but just make sure we know how to find that middle point, that vertex of my parabola. Okay, here it tells us to solve for y. Now, 3 of you I have taught in 7th grade, and I made a big ordeal about this. Because what do I see here? I see the word solve. When I see the word solve, that means my goal is to get the variable by itself. Have you heard me say that? Well, it sure didn't sound like you remembered. So, it tells me here to solve for y, which means I want to get y by itself. Why is y not by itself? Do the opposite. Okay? So in this one, we're going to add 5 to both sides. That's going to give us 2y plus 3x equals 9. Y is still not by itself. Move the 3x over or subtract it, whatever. That's 2y equals 9 minus 3x. So that gives us y equals 9 minus 3x all over 2. It's amazing how my 7th grade things that I kept harping on are back. Okay, so here I'm on page 12 at the very bottom. And they do a quick review of what an intercept is. So an intercept is when our graph crosses or touches an axis. Okay, so in this particular example, my x-intercepts happen when the graph crosses or touches the x-axis. So I have an x-intercept here, here, and here, right? And a y-intercept happens when we cross the y-axis. So in this particular case, there's only one y-intercept. And so just a quick reminder of what an intercept is. Okay, here in this example, we're told to identify all of the x-intercepts and all of the y-intercepts. Okay, so first let's list all of the x-intercepts. That's where we cross the x-axis. So I always like to start on the left side and work my way right. So starting over here, what's the first time the graph crosses or touches the x-axis? It's here at -3, 0. So that's an x-intercept. Okay, where's my next x-intercept? It's at
3/2, 0.
very good, 3/2, 0. And then my next x-intercept is at 4.5. Okay, and does it cross the x-axis again? No, it does not. So those are all of my x-intercepts. Now let's find the y-intercepts. So same thing. I'm going to start at the bottom and work my way up. So my first y-intercept is here at 0, at the ordered pair 0, comma, -3.5. Okay, then the next one happens at 0, -4/3. And then we cross again at 0, 3. And those are all of the y-intercepts.